All right, we're going to do similar as before, except this time we're going to practice using the cosine ratio, and we'll solve for different angles and different sides using the third main trig function. So we're looking for angle alpha over here, so we've got cosine alpha is equal to adjacent over hypotenuse. So the adjacent is 42. That's the short one attached to it. So that's 42. Hypotenuse, of course, is the longest one. So 42 and 47. So if I divide those two out, I got the 42 divided by 47. We get a cos alpha of around 0.89. And then to actually find the alpha, I'm going to take the inverse cos of that ratio. So I'll do the inverse cos of that ratio, and we get around, well, round off, we'll say 27 degrees. So it'll be like 27 degrees. Okay, so the next one here, we've got angle beta over there. So cos of beta is going to be adjacent over hypotenuse. The adjacent would be, well, there's my beta right there. The adjacent would be the 22. And the hypotenuse, of course, the long one is 49. So we got the 22 divided by the 49 gives us a decimal of 0.449. So that's 0.449. And then if we want the actual beta itself, it would be the inverse cos of that 0.449. So we will just inverse cos that answer, and we get an angle of around 63, so that angle would be like 63 degrees. Okay, so next we're looking for some sides. All right, so we've got the cos of 31 degrees is going to be equal to the adjacent divided by the hypotenuse, which is the 58.5. Of course, adjacent is the df I'm looking for. So you can do like a cross multiply idea if you want. So you do the cos of 31 equals times that by 58.5, divide by invisible 1 if you want to, and the adjacent would end up being like 50.1. We'll round up to 50, so no, just round 50.1. So that length would be about 50.1 kilometers. And the next one here, we got 34 here. So we're looking at the cosine of 34 degrees is going to be equal to the adjacent, which again, that's what I'm looking for. So adjacent divided by the hypotenuse of 47.2. So again, you can cross multiply if you want. So take the cos of 34, press equals, times that by 47.2, divide by invisible 1, and we're looking around 39.1. So this would be 39.1 millimeters. And there's 4 questions done using cos theta. All right, well, let's look at another 4 questions doing the same type of thing. Okay, so there's 4 more triangles to work with. Still using cos theta, I know that. So here we got angle alpha again. So cosine of alpha is going to be equal to the adjacent over the hypotenuse. The adjacent would be the 4.3. The hypotenuse is 5.8. So I'll divide those two out. So I got 4.3 divided by 5.8. I'll get my decimal, and then I will inverse cos that decimal in order to find the angle, and we should get around 42 degrees for that angle. All right, next we're looking for beta up here. So the cosine of beta is adjacent over hypotenuse. So the adjacent would be the 5.5, the hypotenuse would be the 5.9. So we got 5.5 divided by 5.9, we get our decimal. Then we'll inverse cos that, and we get an angle of around 21 degrees. Okay, all right, next we're looking for side PR, which is the adjacent. All right, well, I've got the 58, so I'll set it up. I know I'm using cosine. So cos of 58 degrees is going to be the adjacent divided by the hypotenuse, which is 5.2. All right, so we can look at that. Again, cross multiply, so you can take the cosine of 58, press equals, times 5.2, and then you can divide by a magical 1 if you want, and PR, or the adjacent, ends up being around 2.8, it's like 2.76, so we'll just round it, 2.8 AUs long. And then our last one we've got over here, we've got the cosine of 38 degrees. And that will be the adjacent over the hypotenuse, and the hypotenuse is 5.3. So again, another cross-multiplying one. So the cosine of 38, and then we'll times that by 5.3, divide it by 1, and we end up getting AB is approximately 4.2 AUs long. Okay, you don't always cross multiply to solve for a missing side. Sometimes you have to multiply. If you're finding the hypotenuse, you actually would have to do a little bit differently, but this worked out pretty good. Okay, so that's how we can do some of the cosine functions and apply them to triangles.